Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this fourth lecture of module 4. Previously we have discussed about crushed stone and aggregate. In this lecture we are going to discuss about pozzolan, a very important material, and soil. In this lecture we are going to stress and address about pozzolan and soil. In this we are going to cover introduction concerned to pozzolan, some feature of pozzolan, soil and classification, particularly geotechnical perspective. Friends, you can see this material looking like cement, but this is not cement. Looking like cement but not cement. When this material is present independently, this material is unable to show any binding property. However, when we are going to mix this along with some binders, cement or other materials, this material is going to show some binding attributes. First we are going to elaborate what is a pozzolan. Pozzolan is a material rich in siliceous or aluminous component. This material independently or itself have no cementitious value. However, when mixed with cement, water, then this material impart enhanced quality, strength and durability of concrete. Why? Because after mixing with cement, water and other materials, pozzolans started showing cementitious behavior. As far as components are concerned, material rich in siliceous and aluminous content. Therefore, this type of material generally we recovered from igneous volcanic rocks. Igneous volcanic rocks rich in siliceous component and aluminous component, mainly siliceous component. Initially peoples were utilized pozzolan for rock rich in siliceous component and rock belonging to the volcanic igneous rock considered as pozzolan. The powder of such rock peoples were used as powder and mixed along with some cementitious material to improve the quality, increase the quantity and save the money. Nowadays, we have knowledge concerned to the pozzolan, number of materials utilized as pozzolan, some natural, some industrial material like fly ash, like burn slag, like furnace slag, etc. Pozzolan react with lime at atmospheric temperature in presence of water. Pozzolan at atmospheric temperature, T atmospheric, in presence of water produces cementitious compound. This hard cementitious compound Pozzolan react temperature atmospheric, then produces hard cementitious compound. These characteristics makes the Pozzolan specific and useful as construction material. This cheap material mixed with cement on one side going to reduce the consumption of binder cement, on another hand going to enhance some technical property of concrete, lower shrinkage, diminish heat of hydration, improve resistance to attack from sulfate, swells and cracking. So you think independently this material is also have no cost or very low cost, semi-useful, independently has no cementitious characteristics. When going to lime present in cement at atmospheric temperature and presence of water, because in concrete we are going to mix cement, aggregate plus water. So water already present in concrete, and this, if we are going to mix here pozzolan, then the pozzolan lime present in cement, presence of water, and then the pozzolan lime present in cement going to interact and react, and produces cementitious product. As the system is going to produce cementitious characteristic or cementitious attributes, therefore the low cost pozzolan mixing in cement on one side going to reduce the consumption of cement and going to provide some side for saving money. On another side, the mixing of pozzolan in cement is going to improve certain resistance, certain technical characteristic like water tightness, like low shrinkage, like diminished heat of hydration, improve resistance to chemical attacks or sulfate attacks, thermal resistance to thermal cracking, resistance to alkali aggregate reaction. Therefore, we can say that the pozzolan is a very profitable material utilized for economical as well as technical benefit. Now, if we are going to see about the material which can be utilized as a pozzolan, so we can easily categorize two categories. First category is natural and second is industrial. Natural, those rocks or material rich in siliceous component or aluminous component can be considered as pozzolanic material or pozzolan. First and very recognized material is a volcanic ash, same tubes associated with volcanic rocks. These material volcanic ash tubes rich in siliceous component and widely utilized. The powder of such material, volcanic ash and tubes, widely utilized as pozzolan since very beginning, historical past. In addition to this, diatomaceous earth also famous as pozzolanic material. Then chert is rich in siliceous component and utilized as pozzolan. The powder of chert utilized as pozzolan. Pumice stone also utilized as pozzolan. Beside these, many clay, many shell, many silt stone and other rocks also utilized as pozzolan. Simply the concept is a very simple. Certain material react with lime to produce cementitious characteristics, means pozzolanic characteristics. Considered as pozzolan. Certain material like clay, shell and others calcinated at some temperature range ranging from the 600 to 700 started showing cementitious characteristics. Can also be utilized at higher temperature as a pozzolan. In addition to this, various geological formations show huge pockets of shell, silty sandstone, shelly sandstone belonging to Vindhyan, belonging to Kudafa, belonging to Shivalik group in geological term, are showing some pozzolanic characteristic at certain temperature condition. So as far as this natural pozzolanic material is concerned, volcanic ash, tubes, pumice stones, diatomaceous earth, chert, and certain shell, certain clay considered as natural pozzolan. In addition to this, we have industrial pozzolan. Industrial pozzolan, one of the very profitable, very economical. In past it was minus value, minus cost. But now this material has some cost, and this material is a very excellent material recognized as fly ash. Fly ash is a major environmental concern, creating lot of problem in handling, causing air pollution, causing various type of health hazards and others. So on one hand, this material is hazardous to society. On another hand, it is a pozzolan. It can reduce the mixing of fly ash, can reduce consumption of cement, can improve the quality of concrete, resistance to thermal, resistance to chemical, resistance to water entrance, resistance to shrinkage. So people in recent time has started mixing up fly ash to solve one side environmental problem, on another side going to consume cement and going to save money. In addition to this, blast furnace slag also we are going to utilize as a fly ash. Various chimney ash we are going to utilize. Various other residue product subjected to various level of temperature we are also going to utilize as pozzolan. These we have already discussed here. Shivalik clay stone impart pozzolan character after this temperature 871 degree calcination. In Indian context, we are very rich in pozzolanic material in Deccan Trap. Deccan Trap is a volcanic in origin, well known, world famous, have various flow, and this volcanic origin beds contain ash and tubes, and that ash and tubes are considered as pozzolan very early in our childhood time. Nowadays also, the concept of pozzolan term or pozzolanic material come from this volcanic tubes and ash. Then volcanic ash and pumice are also found in barren and Nicobar Island. Diatomaceous earth and radiolarian chert reported from Andaman Nicobar. Sedimentary formations such as Kudafa, Vindhyan, Gondwana, tertiary formations, F capital, tertiary formation including Shivalik, possesses clay and say have a pozzolanic characteristic, but after calcination at certain temperature. Shale and clay beds of all these formations are not equally reactive, but calcination at different temperature going to make this clay and shale as pozzolan. Although clay is also very important for other purpose. So here particularly in context of pozzolans we are going to utilize a very low cost material to save money, because engineering geology is a technically and economically both component approach. Malani rhyolite located in Rajasthan and in part of Jammu, Srinagar and others also utilize pozzolan material. Means India is a very rich in pozzolan materials and people nowadays well familiar about pozzolan and utilizing well, saving money on one hand side and taking technical benefit on another hand side. Many others also, some clay and other, but clay is still a costly material and utilized for various medical, cosmetics and others, many purpose. So we generally prefer low cost material, lower than cement. Next important materials engineering geology is applying or working soil. Soil are various types. Soil we are utilizing as a subgrade in case of road pavement, airport, many building foundation, dam foundation, bridge foundations. The soil, keeping importance of the soil, we are going to utilize the soil as earth in engineering geology or engineering context. Where we are going to discuss about the soil, in honor of soil we are going to use term earth. For example, earth dam. Earth dam means soil dam. Soil is a very interesting material. Peoples of various disciplines are interested in study of soil, like agriculture scientists, civil scientists, soil scientists, even medical scientists. Various researchers are going to see the soil from different point of view. As for our concern, we are also going to see soil in our point of view. Genetically, the soil is a product of weathering and decomposition of rocks. The weathering and decomposition means disintegration and decomposition of rock. These two, disintegration and decomposition, are class of weathering. Mechanically weathering, disintegration. Chemical weathering or chemically weathering, decomposition. So, disintegration and decomposition of rock responsible for production of soil, as well as formation of clay under certain specific EH, pH and biological components. In general, rivers, waters and other responsible for the formation, accumulation of sediments. When the sediments is going to include some organic component, then agriculture people and other people also started recalling the sediments as soil. Large projects and a soil as a material widely utilized in field of engineering geology. When we are going to see soil in our point of view, then we can categorize soil in three categories, considering the factor concerned to constituent. It is homogeneous, heterogeneous. Another thing about the permeability status, about the porosity status, and about the ability to sustain with external load. So here we are going to categorize. The soil can be categorized in three categories: pervious soil, semi-pervious soil and impervious soil. Pervious soil, as the name indicates, it is constituted of or comprised of homogeneous material free from large void and will consolidated excessively under the super incumbent weight of the field. Large void present and has high angle of internal friction and low cohesive strength, permeability greater than 50 into 10 to power minus 4 cm per second. In case of impervious soil, this is heterogeneous in nature, low angle of internal friction, high cohesive strength and low permeability. This low permeability, here K is less than 0.01 into 10 to power minus 4 cm per second. Between here one thing we have to correct: homogeneous material where large voids are present. Therefore, this pervious soil is going to show low cohesion due to presence of voids, high compressibility and high angle of internal friction. As per we have already discussed, as per our concept, Mohr-Coulomb's concept, angle of internal friction if more, then this cut which representing cohesive strength C is less. So if this value is high, then C is less, means soil is weak. Compressibility more, can be compressed more. Impervious soil, heterogeneous in nature, the wires are filled by another material. You can see here the homogeneous, then wires, existence of large wires are still present. If heterogeneous, in between bigger component there is a smaller component which is going to occupy. Therefore, in impervious there is a very less permeability, high cohesive strength and low angle. This become like this. Low angle, value of C is more. If wires is less, then value of C is more. In general, not always true, but approximately. And if this angle of friction, wires are more, angle of friction more, value of C less. In between these impervious and pervious soil, number 1, number 2, in between these there is transition, that is the semi-pervious. Semi-pervious have characters, partial character of the pervious and partial character of the impervious. So semi-pervious soil has medium cohesion, medium angle of internal friction and medium permeability, and K is ranging from 0.0, lower boundary of this impervious 0.01 into 10 to power minus 4 cm per second to 50 into 10 to power minus 4 cm per second. In this way, by knowing the compressibility, consolidation indirectly, and about the cohesive strength, about the angle of friction, about the permeability, we are able to consider this for various purposes, considered as a foundation for construction of dam, construction of building, construction of bridge foundation, road pavement as a subgrade, etc. In addition to this, we can develop some dams also, earth dam, earth house, etc. Next is a clay material, clay present in soil, and we are recognizing as a clay soil. Clay soil is a very important, and this clay soil we require in construction of embankment, retaining walls and abutment. More than 50% particles of clay present in soil recognized as clay soil or clay. If it is a compact in nature, then we are considering in form of rock argillites. This clay soil or clay is constituted of either non-clay minerals such as quartz, feldspar, calcite, mica, clay minerals, or clay minerals, kaolinite, illite, montmorillonite. If you see these clay through XRD, then you can get certain type of peaks. Any soil or any clay, quartz always present, calcite also present, some feldspar also present. Why? Because feldspar is directly or indirectly parent of clay, majority of clay. Some of the clay minerals, famous clay mineral, kaolinite, illite and montmorillonite. Here this montmorillonite is showing a maximum expansion in volume after interaction with water. It means the strata containing clay having montmorillonite if able to receive water, then it started bulging, and this type of bulging is a chemical interaction and recognized as swelling. So Montmorillonite is a very sensitive to swelling. Clay mineral, analysis of clay mineral, we are going to involve X-ray diffraction, differential thermal analysis and others. These are costly analyses and slightly beyond our scope. We are not more interested about the chemistry, we are more interested about mechanical or geotechnical response of soil or clay with respect to external cause. Although as per demand of the topic, the clay minerals are crystalline hydrated silicate of aluminium. The clay mineral is actually combination of octahedron and tetrahedron. In certain cases there is a gap. In this gap, the water is going to enter and going to enhance the volume of clay minerals. Therefore, Montmorillonite is going to show expansion in volume and swelling. In some clay minerals, sodium, iron, magnesium may be present, and the clay soil constituted of the large percentage of clay mineral exhibit high plasticity, low shearing strength, and volume change swelling when saturated with water. Water, the interaction of soil and water, or soil and earth. Earth means soil. Soil and water is a very interesting. In every steps of engineering geology or civil engineering construction or any development work, we are going to face soil and water. Water is going to interact with soil. If clay mineral is present, it can show some swelling, it can show some change in plasticity, it can show some change in liquid limit. These are engineering properties of the soil. We may study if time requires and situations allow. Swelling behavior, when this type of soil based swelling behavior is used in engineering construction such as embankment, it may result in settlement of the body of the engineering structure and slope failure in saturated condition. Good example we have in case of tunnels, when we are going to encounter clay, swelling clay. The swelling clay is a very problematic because it is going to increase the load on the support system, and the access of the water, if available to such material in any season, there is increment in load and creating lot of problem in field of tunneling if going to encounter clay of swelling nature. Here I have collected from this reference 1969 given in book Engineering Geology. You can see here some of the component. Some typical soils belonging to some black soils close to volcanic terrains. In India, we can see nearby the Indore and others, Khandwa and others. The area dominated by Deccan Trap, weathered in nature and come in form of black soil. And black soil is very important from agricultural point of view. The black cotton soil having clay fraction 55%, means close to clay. The liquid limit is 73, where the plastic limit is 40. However, in case of the clay from the delta area like Sundarban and others, the clay fraction is more 66, liquid limit is more 80, and plastic limit is also more in comparison to the black soil. The clay from the coastal sea coast area, clay fraction is 80%, liquid limit is 90%, clay is 80%, liquid limit is 90, not percentage, and plastic limit is, it is index 63. Then clay of still water means clay from the lake and pond and other. Then the clay is a 55% close to the black cotton soil. However, the liquid limit is more and plastic limit is same, close to the black cotton soil. It means the saturation of clay present in lake or pond may be same as the black cotton soil. Here in case of still water basin, the clay may be interacted with some nutrients, vegetations and others, degradation of vegetations and others. These are some details concerned to the particular, beyond our scope, is only for your knowledge. Friends, these material can be well studied from the book written by the Gangopadhyay, Shobindo Gangopadhyay, in his Engineering Geology, very excellent book, Engineering Geology, published from Oxford University publication, and then take help of standard book, Engineering Geology, written by Bell F.G., and then Waltham, and then Kashabulu, along with some materials concerned to the agriculture science and other material available through website or web. Friends, as we have already discussed, Pozzolan is a natural as well as industrial material. It has no cementitious attribute independently, but when mixed or interact with the lime present in cement, in presence of water at the normal temperature pressure condition, going to show cementitious property, and this is the main mechanism behind the working of the pozzolan. The mixing of pozzolan in cement reduces the cost through reduction in consumption of cement. And the mixing of the pozzolan in cement is technically resistant to heat shrinkage, reduce alkali aggregate reaction, attack, chemical attack, heat resistance, and many. Dear friends, in this class we have discussed one of the very important material which are going to reduce the consumption of cement and provide some safety to our pockets. Then another interesting material is a soil, and in engineering geology we are going to widely interact with soil at different levels as a ground for development of road alignment and many structure and construction of some structure like earth dam and others. Thank you very much.